Hi everyone, this is Avni Singhal. Today we are going to talk about my CWS project, that is elevator simulations. So let's get started. So first we are going to talk about what does this code do. Basically, I have written here a code about simulating a single elevator in a building. Basically, what does this code do is it decides the order in which the elevator goes up and down based upon the request or input given by the user. For example, if I am on the second floor of the building and I have to go to the fifth floor, and if there is a person on the third floor who has to go on the first floor, and the elevator is currently on the zeroth floor, that is ground floor. So what will the elevator do is it will first go to the second floor, then it will go to the third floor, pick the another person, then it will go to the fifth floor, which I had requested. As it is going upwards, the elevator will only move in one direction as we want to optimize its motion. Thus it will move in one direction only by serving all the request in one direction. That is, it dropped me at the fifth floor, then it will continue its downward motion. That is, it will go from fifth directly to first floor that the another person had requested on the third floor. Before moving on to the main code, first we need to learn about some new topics like class. Basically, what is class? It is a fundamental building block of OOPS, which is called object oriented programming. Basically, it's a user defined blueprint or template which is used for creating objects, which helps us to bind the data and the functions together in a single unit. Basically, we can think it of as a cookie cutter. That is, it defines the data, like we are defining the ingredients of the cookie, like flour, sugar, eggs, that an object should hold. Okay. Then it defines the actions which are to be performed, like mixing and baking, that are to be performed on the object. Right. So basically, what does class do is it relates those data and function, keeping them together in a single unit or a single package. And when we use this blueprint to actually make something, that something is called object. That is the actual cookie. So basically, the class is the core part of the OOP. Now, another important concept that we need to know about is set. Before starting the code is set. It is a type of data structure that only stores unique element, and that too in a sorted order, that is usually ascending order. Now, how we define set is we write set, then in that angular brackets we define the type of data type that we want to store in the set, and name a variable then we name a variable such as variable for a set, such as here I have defined it as st. Now here, as I have said, integer is the data type, st is the variable name for the set. Now if I want to, like, in the upcoming code, there is a part in which I have to store the number of the integer of the floor in descending order too. So for that, what I have done is I have chose greater integer. That is, this tells the set to store the given unique elements in the descending order. Okay, what is the significance? Basically, it helps to automatically sort the floors in the elevator code. Like, it sorts the order in which lift move between the floors. And how does this set work? Basically, if now, like, if I have been given an input like 2 4 1 3 5 2, so how the set will sort it? Now the set will sort it as 1, 2, 3, 4, 5, and it won't be repeating the 2 again. It will only store those unique values, like, and that too in ascending order. We can see it as ascending order, right? This is the significance of set in this code. Now from here the code begins. In this first snippet of code, we are basically including the essential libraries which we want in our code. Here hash is a preprocessor directive, and basically hash includes tells our processor to include these header files that are essential, that are standard libraries to be included in our code. Like here, in first line, it is hash include iostream. Iostream within the angular bracket. That this iostream which is in the angular bracket is basically our header file, or we can say a standard library, one of the standard library. It is basically read as input output stream. What it does is it helps us to access the basic functions like cout and cin. Without including this, we can't do cout and cin. Basically, what it does is it helps us to communicate with the user or matlab on the console, like taking in information and giving in output. Basically, it helps with this standard cout and standard out cin. It helps with this. Now next is hash include set. Set is another um, that container which we are going to use, as I have previously told in I have told in previous slide what is set. It is basically we are including it in our code, telling our code that there is something called set. Then there is hash include vector. Now the fourth line, which is going to be very useful in our code, is using namespace std. Basically, it is a kind of a shortcut that we are using in our code. Basically, it is telling that we are going to use this std, which is also called standard, everywhere in the code wherever it is needed. It is going to save us a lot of time and will make our code much more readable and neat. Basically, what will it will basically this std will help us, basically this using namespace std will help us, so that help us in such a way that so that we don't have to write std double colon, sorry, std double colon in front of every standard library function whenever we see it, like std double colon cout or std double colon cin. It saves us a lot of time. In these private members, basically these are the variable which are only accessible in the class itself. It's like we can't access them directly from the main function in the code. If we want to access them from the main function, then what we have to do is we have to like define an object which will then call these variables from of private members in the code, which will call these private member के variable in the main function. We can't directly call them in the main function. Whereas जो public members होते हैं, they are the functions that can be called outside the class that we can directly call in the main function. Like we can just write their name in the main function, then we can call them directly by writing their name in the main function. But we can't do the same with the private members. For example, here in this code we can see that in private members we have defined current floor. I have defined current floor. Second, just a second. Now here I have defined current floor. Basically, I am telling the basically user is telling their current floor. Then there is total floors. Total floors is basically defining how many floors are there in the building. Then we have, as we can see here, we have defined a set like this. Set angular bracket integer up request. So as we have discussed earlier in the earlier, as we have discussed in the earlier slide, here up request is name of the variable. Here up request is name of the variable, and its data type is integer. Basically, what we are storing in this set is we are requested to store all the floors that are above the current floor. Like if I'm on the second floor, then I'm going to store all the numbers of the floor which are above second floor. Okay, from 3 to whatever number of maximum floor are there. Then and also I am going to store it in an ascending order, which is exactly what we want in the upward level, right? From least to most. Next, I have defined another set named as down request. Variable name is down request. And here I have written something like integer comma greater integer. What is the meaning of this? Basically, by writing this, I have tell the set that I want to store whatever integer I am giving in the descending order. Like, that is from highest to lowest. Basically, greater integer is a custom operator. Greater integer is a custom operator which is used to store all the requested floor below the current floor in descending order, so that when the elevator goes in downward motion, it always addresses the highest number floor first, right? Then in public member, I have written like elevator integer floors, current floor equal to 0, total floors equal to 4 floors, total floors equal to floors. What I have done here is कि first in the main function I would be taking an input of integer floors, which I have written here within the parenthesis. That is, we are talking about floors, whatever input is in the floors. Then I have initialized a variable called current floor to 0, and total floors is the input that I have taken from the user. Sorry, total floors is the integer that I have, that is also defined within the parenthesis, like this floors, right? That is total number of floors within the building. Okay. So here we have defined another void type function within the class, elevator class. And whenever we define any function within the class, it is known as a method. That function is known as a method. Here we are using a void type function which is named as request floor. Void type function basically performs only a set of instruction but does not return any value. Here we have taken within the parenthesis of this function, we have taken integer floor. Basically, what is floor? Floor is the requested floor on which a person wants to, that is, a user wants to go. In previous slide, I had said that the floor is total number of, integer floor is total number of floors in the building, but it's wrong. It's the requested floor. Now, within this void request floor function, we have some if-else statements. Like first if statements has condition of floor lesser than 0. Then these two standing lines are there. It tells the or condition, or floor greater than equal to total floors. Basically, it is telling this condition or this condition. If any one of them is true, we are going to see out invalid floor request and we are going to return. Okay. Then second, if statement states that if floor is greater than current floor, then we are going to insert this integer floor. We are going to insert this integer floor inside the set which is has variable name as up request, because it is greater than the current floor, then which that means the elevator has to go up. So for elevator has to go up, we have defined a set with variable name as up request. We are going to insert the integer in that set, and we are going to see out a statement as request accepted for the floor and whatever the request was. Okay. Or else if condition is going on, that is, if floor is lesser than current floor, then we are going to insert it in down request set. Similarly, then we are going to see out request accepted for the floor and the current, whatever the requested floor it is. And if none of them is true, then we are going to see out is elevator is already at that floor, क्योंकि इसमें हमें दिख रहा है कि हमने सारी conditions check कर ली हैं. That is, it can be either greater than current floor, lesser than current floor, or it can be an invalid input, like it can be negative, or it can be greater than the total number of floors. Only condition left is, what if the requested floor is the same floor as the user is on that floor only, right? So if none of them is true, then we are going to see out elevator is already at that floor. And here, like just wanted to tell that this is the general way of inserting any variable. If I have taken, sorry, not variable, data type. Like if I have taken integer as a data type for the particular set, and the set variable name is st. So how will I How will I insert a new integer within that set is st dot insert, and that we can, within the curve brackets, we can write 2. Like if I want to insert integer 2, then I can write 2 within the bracket. Now here we are talking about another void function which is defined within the elevator class. Its name is void move. Here it contains two nested while loops which are responsible for all the downward and upward motion of the elevator. The first while loop is responsible for all the upward motion of the elevator. Here we can see curve parenthesis we can see it is written as exclamation up request dot empty. Basically here what is exclamation mark? Exclamation mark is the logical not operator in C++. In C++, it represents logical not operator. That is, this condition tells us that until and unless the up request set, which we have previously defined, is not empty, this while loop will iterate. Like this while loop will keep um going on until and unless the up request is not empty, up request set is not empty. Okay, so within this first while loop, what we are seeing, which is responsible for the upward motion of the elevator, we are seeing that we have defined an integer known as target, which is equal to star up request dot begin. Basically here this star or asterisk, we can say, it is a pointer and it point towards the first element of the set up request. Basically whenever, like, if I have a set called set with variable name dot st and I write and I so whenever I write like st dot begin star, basically it represents the first element of the set container with variable name st. Okay, so here I have taken target as star the or asterisk up request dot begin, basically taking the first element of up request set container. Okay, now what I am doing is, if this condition is true, if the given condition is true, that is up request set is still not empty, then my target is the first element of the up request set. And what I am going to do is I am going to erase the first element of up request set and see out. And after removing it, I am going to say see out elevator is moving up from the current floor to the target. And their next nested while loop within this loop is given as if the target is greater than current floor. If in this while loop the condition is that the target has to be greater than current floor, then what we will do is we will do current floor plus plus and we will see out add floor current floor. That is, after doing a plus plus, that is after adding 1 to the current floor, we have new value of current floor, so we will print that new value, that is add floor this, like uh, and after when this while loop is executed, and after that we will print reached current floor. Okay, so basically if I take an example, like if I am on first floor, if I am on first floor, my target my target is second floor, right? From first floor, the elevator is at first floor, I have to go on second floor. Okay, I have to go on second floor, so the first element in my up request set will be 2. It will be 2. So this means that up request set dot begin, that is this will represent 2, so target will be set to 2. Now now it is written as up request dot erase the given element. Okay, given element for which, for my example, is 2, right? So up request dot erase 2, now 2 will be erased. Now see out will be the elevator is going up from 1 to 2, that is 2 is our target. And next then another while loop will be executed, that is still as 1 is lesser than 2, the current floor will become plus plus, that is we will add 1 to the current floor, that is we will add 1 to the first floor, that will become 2. Now we will be like add floor 2. Then after this while loop is executed, we will be printing reached floor, current floor is 2, so reached floor 2. Similarly, if we have to go down, so I have second while loop which represents the downward motion of elevator. Similarly, as up request dot empty, similarly it has like if the up request set is not empty, then this while loop will be executed. So integer target is equal to star down request dot begin, that is representing the first element of the down request set, which would be the largest number in that set, because down request set we had defined it in the descending order, right? So it will be the largest number in that set. The target will be that largest floor in the set, right? Then down request dot erase, what we are erasing, the largest floor in that down request set. Then we will be see out, what will be see outing, that elevator moving down from the current floor which we are at to the floor which we are going, that is target, the largest floor in that down elevator set, down request set, sorry. Another while loop that will be executed is, if the current floor is greater than the target, we will be subtracting one from the current floor, right? Like if I am on fifth floor and I have to go on third floor, then this code will be running like 5 is greater than 2, so minus, then it will be 4, then we will be like we are at floor 4, reached 4th floor, right? Then again the whole while we will be like, oh, while loop is sorry, down request set is not still not empty, there is 432, right? 432. So it will be like, the now the target is 4, now we are going to erase 4, we are going be like, we are being like, current floor is 4, we are going to the target 3, sorry, here target will be 3, sorry, here target will be 3, we are going to the target 3. Now it will be like key 4 is greater than now the target is like 4 is greater than 3, this will be running, right? This is all while loop will keep running until and unless we reach the second floor from the fifth floor, right? This is all for this move function. Like another thing that we had to look at was like why we are removing the first element of that up request set or down request set, was that so we don't try to go on the same floor again and again. So and also that loop should have eventually terminate, right? It shouldn't be like going infinitely. That's why we were removing the elements, first element of those particular set again and again, so that we don't repeat those flows. Like this is what all the content that I had explained in the previous slide, the same is written here. Now the last part of our code is the main function. We have defined the main function of integer data type, that is it will return an integer data if it wants to return. Then here within the main function we have defined a total floor integer variable which is initialized value as 10, that is our building has 10 floors, 0 to 9. Then I have called the elevator class, in which I have defined lift as an object which in which I have taken integer total floors. Okay, then I have defined another integer variable known as request, and I have see out a statement. Please enter the number of requests, that is number of floors the person want to visit, and taking an input of the integer request from the user. Then I have see out another statement like enter the requested floor, and I have defined a for loop for taking input from the user for each floor, that is for integer I lesser than equal to 0 and lesser than request I plus plus, that is this for loop will run for uh, number of time equal to request, number of request, it will run for number of request. And within this for loop I have defined a temporary variable f for each iteration. This we will take input from the user and store in this temporary variable f, and here we can see it is written lift dot request floor f, right? This means the lift object calls the request floor method in the class, where this request floor method basically sorts this f according to the conditions uh, conditions which are stated within the request floor function, request floor method. Then after this for loop is executed completely, or then the lift method calls the move method that is move function within the class, where the move function, as we know, it is responsible for all the upward and downward motion of the elevator. All the things take place accordingly, all the things take place accordingly. And another thing that I forgot to mention is that as we see here, request floor, right? Request floor method, what it does was key, it basically inserts this value of temporary variable f into either up request set or down request set according to the condition, right? Okay, this is fine. Then as we were here, like lift object calls the move method within the class. All the motion, upward and downward motion of elevator take place accordingly. Then after all the while loops or um, nested while loops which were present within the move method are executed, we can see here it is return 0. That is the execution of the main function is completed and the program gets terminated. So here is the actual code of the elevator simulation. Like here we can see the hash include IOStream, hash include set using namespace std, the first snippet that I showed. We can see here the elevator class that we had defined, under which we had defined private and public members, right? Then there is the first void function under this class, that is request floor, which checks if the floor input of the floor which is given, if it's valid or not, and whether the floor request, that is the input that the user has asked, is above the current floor or below the current floor, or is equal to the current floor. Then we have the move function, or we can call it method, which is the most important part of this code as it decides the motion of the elevator. Then we have the main function here, in which we have initialized the total floors of the building in as 10. And here under the elevator class, I have defined an lift object which take total floors as in the input, that is consider total floors equal to 10. Then I have defined another, then I initialize another integer variable known as request, and I have taken input from the user how many number of floors they have to visit. Then I have then we have done another cout, please enter the requested floor. That is, by using this for loop, we are taking the input of the floor that the user has to go one by one in this temporary variable f, and we are storing it in the request floor set that we sorry, not request floor set, in the request floor function that we have defined. And for that temporary variable f, this whole uh, this whole if else statement is being executed for the particular temporary value of variable f, right? Thus, for every f, it is uh, going through this piece of code, right? Then, after executing this for loop, we are the lift object calls the move method within the elevator class, and which runs to complete the simulation of the elevator. And then, after all these things are being executed, we come back to this return 0, and by this return 0 it means the compiler gets that key, the code is terminated. मतलब all the function that had to be performed are performed, and now the code is terminated. Now basically let's for example, let's see this code. Let just see here that it is asking for number of requests. Let's say my number of requests are 3. Enter. It asks for enter requested floors. So let's say my requested floor is 5th, then 4th, then 1. So the it is showing something like this. right? My fifth, fourth one are my request. So it shows like elevator is moving up from 0 to 1. As we know, I already said that the code, the code, sorry, the elevator is initially at ground floor, right? So it will go from 0 to 1 at floor 1, reached floor 1, right? Then elevator is going from 1 to 4th floor. So at floor 2, at floor 3, at floor 4, reached floor. Similarly, going 4 to 5, at floor 5, reached floor 5. And another thing like uh, another example that we can take is like if I run it again, right? Just remember that just remember that here I have initialized the total floors as 10. That is, it can't go above 9 as it was 0 to 9, right? So if I run this code now, okay, let's say number of requests are 2. The requested floor I enter is 1 and 11. As we know, it can't be greater than 9, right? Because it's 0 to 9. I have initialized the total floors as 10. Okay. So here we can see is requested floor accepted, request accepted for the floor 1 up. 11, for 11 it is showing invalid floor request. Elevator growing from 0 to 1 at floor 1 this. I just wanted to show that if we enter a number greater than 9, then it will show the invalid flow request. So from here we can say that the code works properly.